Algebra 1, welcome to Chapter 3, Lesson 5. In this lesson, we're going to be talking about transformations of linear functions. So we're going to talk about how a graph moves in different directions. How it moves up, how it moves down, right, left, as well as how it changes direction. So something going up could change to going down. So our objective today is to identify the effects on graphs of linear functions by replacing f of x with f of x plus k and f of x minus h for positive and negative values. We're going to identify the effects of graphs of linear functions by replacing f of x with a of f of x, f of a of x, a negative a of f of x, and f of negative ax. Now these might look very complicated and kind of hard to understand, but I'm going to break these down in this lesson and I'm going to show you what these mean here. Certain things that we see tell us to do certain things to a graph, and it's going to change a graph by moving it either up, down, right, or left. Alright, in this lesson we have 4 vocab words that we're going to actually break apart, and then we're actually going to be doing these vocab words in the lesson. So we're talking about transformations of linear functions, how they move. So a transformation of a linear function moves the graph on the coordinate plane to create a new linear function. That's what we're going to be doing. Translation is when we move a graph left, right, up, down, or we can move it 2 directions at once. So we can move it up and we can move it right. That's a translation. So a translation is when we move a graph up, down, left, right, or 2 directions at the same time. A dilation is when we stretch a graph or compress a graph of a function. Now a stretch brings it usually closer to the x value, or we can stretch out to the y's or the x's. So a stretch will bring us closer to the y, or it could stretch us out towards the x values. We have reflections. It's going to flip the graph of a function across a line. So it can reflect it over the x-axis or over the y-axis. And that's what we're going to be doing in this lesson. So these are the different types of transformations that we're going to be doing. Let's go. I want you guys to take a few minutes and copy down what we see on the board here, because this is one of the first things that we're going to be doing. This is our first key concept. So in this lesson, we're going to have a few key concepts. They might take a little bit of time because you're going to draw some pictures of graphs that's going to represent what's happening. Once we actually start getting into the questions, they're going to go fairly fast because we're just going to talk about the rules from the key concept. So the first thing we need to understand is we need to copy this down in our notes. So make sure you got it. I'm going to go ahead and talk about this. So if you haven't yet, pause this and copy everything that we see down. I'm going to talk about what we see here. So the first thing we're going to talk about is how to do a transformation of a graph. This first transformation is either going to move our graph up or our graph down. So if we add a constant to our equation, any equation in mathematics starts from this equation right here, as long as it's a linear equation. Y equals x, or f of x equals x. If I had the equation f of x equals x, it goes through the origin, it makes a straight line, it goes up 1, it goes right 1, goes up 1, goes right 1, makes this graph here. Now, the rule is, if I add a number to that problem, so f of x plus 0, if I add a number to that problem and that number is bigger than 0, what's going to happen is this graph is just going to move up whatever number I add to the problem, as long as it's bigger than 0. So it's going to move k units up. Whatever that number is, as long as it's bigger than 0, it's going to move that many numbers up. So if I had f of x plus 4, that means the graph would shift up by 4 units. Every point on the graph of f of x moves up by the absolute value of k units up. So whatever that number is, as long as it's bigger than 0, it's going to move up by that number. On this side, we're going to talk about the number that's adding to our problem. Instead of it being bigger than 0, now it's less than 0. So if our number that's adding to the problem, f of x plus 0, so our regular standard linear equation, if our number is smaller than 0, what happens is the graph moves down. It moves down by whatever that k is. So this is usually when you see that negative number. So if I had f of x equals x minus 3, this graph would move down by 3 units. If I had f of x equals x plus negative 7, it would still go down by 7 units. And that's because it goes down by k units as long as that number that we're adding at the end is bigger or less than 0. So this is our answer to this problem. So now we're going to actually practice this piece by seeing what's happening to a graph. This should go pretty quick as long as we understand. If it's bigger than 0, we go up. If it's less than 0, we go down, but it's got to add to the number at the end. So f of x plus 0, it adds to that number at the end, and that's what moves the graph. So in our first example, all we got to do is say what happens from f of x to get this. It says describe the translation in g of x. So in this equation here, there is a translation that occurred. So a translation moves a graph up, down, right, or left. So we need to describe what's happening in this translation. So we have x plus 8 as it relates to this graph. So if I started from this graph and I get to this graph, we need to describe what happens. So what we're looking for is a number either adding or subtracting at this point. Something bigger than 0, something smaller than 0. And that's that 8. Since it's adding or subtracting at the end, that's going to move a graph up or down because this is the k value that we're talking about. So in this problem, k is equal to 8, which means that since that's a positive 8, our graph moves up 8 units. Because if it's a positive number and it's bigger than 0, the graph moves up. If it's a negative number and it's smaller than 0, the graph moves down. And this is based off that slide that we just looked at. So since we're adding 8 at the end, the graph moves up, and that's our answer to this problem. So we just talked about how a graph moves up or down. Now it moves up if that number is bigger than 0, and it moves down if that number is less than 0, but it adds outside of parentheses. So now we're going to look at problems that have numbers inside parentheses. So we're going to talk about grouping with a number inside of f of x. So grouping means inside parentheses. So we're going to have a number inside parentheses. And if that number inside parentheses is bigger than 0, then the graph of f of x is going to translate to the right by whatever number is inside there. So if it says x minus a number that's bigger than 0, the graph moves right. This one says if that number is less than 0, the graph of f of x is translated 8 units left. So if it says x minus a number that's less than 0, so minus like a negative number, then that graph would move left by whatever number's in there. So think about this. This one is minus a positive number, moves the graph right. This one is minus a negative number, moves the graph left. Now we know that two minus signs make a positive. Minus negative makes a positive. So the number that we're going to see here is going to look like a positive number inside parentheses, but it's really telling us to move the graph left. The number in here is going to look like a negative number, but it's actually a positive number because it's x minus a positive number, a number bigger than 0. So whatever number that's here, as long as it's bigger than 0, moves our graph this way that many units. Every point on the graph is going to move that many units right. Every point on the graph is going to move that many units left. So what I want you to do now is I want you to copy this slide down, make sure you have it, so that way you understand what the grouping symbol rule is. So we talked about ones that don't have grouping symbols moving up or down. Now we're talking about grouping symbols moving the graph to the right or to the left. So we're going to do one example that relates to moving a graph right or left. We're going to do this example right here. So it says, describe the translation in g of x. So there's a translation that happens in this equation here as it relates to the graph of f of x equals x. So we're going to describe what translation we view has happened in this problem. So we're going to look up here. This says x plus 3. So that's a positive 3, but it's x plus 3. And we know that in translations, what we really have is we have x minus h, if it's going to go right or left. And this is a right or left translation because it's happening inside parentheses. So we're going to be subtracting h. Well, if I subtracted a positive 3, x minus 3 would look like this. And in this case, we have to subtract a negative 3 because two negatives change into a positive. So this 3, or this h value, is actually a negative 3, not a positive 3. Even though it looks like a positive 3 here, if we think back to what we just copied down, it says x minus h. So the number that's here is actually being subtracted to make this sign that's in the middle. So if it was just minus a positive h, it'd be x minus 3. Since it's minus a negative h, it would be h is negative 3. Since it's a negative 3, a negative means our graph moves to the left by 3 spaces. So in this case, we would say the graph is translated, because a translation moves the graph left, right, up, or down. Is translation, no, it's translated. So if we want to describe what happened from this graph to that graph, the graph moved left by 3 spaces. And that's because the plus is actually two negatives. Two negatives make a positive. Alright, take a few seconds and copy down everything that you see on this screen. We're going to talk about vertical and horizontal stretching and compressing. So make sure you copy this down because we're going to talk about graphs getting more steep and less steep. Alright, I'm going to go ahead and start by talking about the right side, and then I'm going to move over to the left side. So, what we're going to first talk about is we're going to talk about a basic graph having a 1 slope, which means that we go up 1 and right 1, and that makes this green graph here. Now, the number that's multiplying by x, or in this case, our a value, if our number that's multiplying by x, if we look at it and we take its absolute value, so negatives don't matter, but if we take that number's absolute value, if that number's absolute value is bigger than 1, then the graph of f of x becomes steeper. What that means is the graph is going to get closer to the y-axis. So if our graph starts here, it's going to shift closer and closer to the line that's labeled y. And the closer it gets, the more steep it is, because we would never want to run down something that has the y-axis. We might ride a roller coaster that has the steepness of this, but we're hoping it comes out of that steepness at some point. Now, down here, we have the two different types of things that happen when we get closer to the y-axis. So we need to think about the number that's multiplied by x. That's called our slope. We're going to talk about our slope in this problem. If our slope, or the number that's multiplied by x, is outside parentheses, then that's something that's vertical, which means we're going to use the word vertical, and then we're going to say what's happening vertically. So since this a is outside parentheses, that means our graph that has a 1 slope is going to vertically stretch and get closer to the y-axis. So we call it a vertical stretch if it gets closer to the y-axis if it's outside parentheses. Now, if that number that's multiplying by x, or our slope, if our slope that's multiplying by x is inside parentheses, then we're going to call it a horizontal compression. So what that means is if I had a graph that had a 1 slope, I'm going to compress horizontally. Now, if you're compressing something, you're usually pushing away. So we're going to push away from the horizontal axis. And if we're pushing away from the horizontal axis, we actually get closer to the vertical axis. Now, on the other side, the opposite's happening. Instead of getting further away from the x, we're going to now get closer to the x. So, if the number, our a value, if our number that's multiplied by x, or again, our slope, if our slope is between 0 and 1, the graph of f of x is going to become less steep. So that means it's going to get closer to the x instead of closer to the y. If we get closer to the y, it's steep. If we get closer to the x, we can almost walk across it, and we're good to go. So we're going to get closer to the x in this problem. So here it says f of x equals ax, and that's a vertical compression. So this a is outside parentheses, and if it's outside parentheses, we need to remind ourselves that that's vertical. Vertical is something that happens outside. So the number is between 0 and 1. It's bigger than 0, less than 1, and as long as it's a decimal or a fraction, it's going to get less steep. So if we have a slope of 1, we're going to get closer to the x. So again, if it's outside parentheses, we call it a vertical compression. So if I had a slope of 1 and it's outside parentheses, we're going to compress vertically. Compression means we're pushing away from the vertical axis. So we're pushing away from a line that's going straight up, so we're going to get closer to the x. Now, if it's inside parentheses, we're going to call it a horizontal stretch. Horizontal because it's inside parentheses, and a stretch because when we stretch, we get closer and closer to that piece that we're looking for. So we're getting closer to the horizontal because we're stretching out towards the x. And that's what we're doing in this type of example. So we're going to look at a number next to variable, and we're going to decide, is it vertical, is it horizontal, is it a stretch, or is it compression? Alright, so in this example, we're going to describe the dilation between these two equations. So we're going to describe what happened to get 14x if we started with f of x equals x. So we're starting with 1x, and we're going now to 14x's, and that 14 is inside parentheses with the x. So the first thing we need to do is identify what changed. Well, it went from 1 to 14. So if it goes from 1 to 14, it's getting bigger, and that number is bigger than 1. So our a value is greater than 1. So if it's greater than 1, we need to think about what we just saw in the previous slide. If something's greater than 1, it's going to get steeper, which means that a graph that goes like this is going to get closer to the y-axis. So our graph is going to get steeper. Now we need to see about the fact that it's in parentheses. Since it's in parentheses, this is where we use the word horizontal. Horizontal. I can't even spell it right now. Horizontal. Alright, so this is something that's going to be happening horizontal. So this is horizontal something. So if I have a graph like this, and I want to get closer to the y, but I'm thinking about the x-axis because I'm horizontal, what's it doing to the x-axis? Is it getting closer, or is it getting further away? Well, hopefully you're thinking about the fact that it's getting further away. And if it's getting further away, the x-axis is kind of like pushing it away. So this is called a horizontal compression. And it's going to horizontally compress, and it's going from 1 to 14, so it's horizontally compression by 14. So that means that we're really just multiplying by 14. We have a horizontal compression of 14. Alright, so the final thing I have to teach you is about reflections. And to me, reflections are probably the most simplest one. So what a reflection does is if we start with a graph going up from left to right, so if we start with this green graph, and that's our function f of x, a reflection changes a graph that's going up to now going down. So reflection just makes the opposite happen. If the graph was going up, it goes down. If the graph was going down, it's now going to go up. Now we have two types of reflections. We have a reflection across the x-axis, so make sure you copy this down, and we have a reflection across the y-axis. Make sure you copy this down. And if you look at these two pictures, they're pretty much exactly the same. That's because they are exactly the same. The only thing that's different is the number that's multiplying by x, kind of like our vertical and horizontal stretches and compression. The number that's multiplying by x, or our slope, is going to tell us if it's going to be across the x-axis or across the y-axis. So if our slope is outside of parentheses, then it's across the x-axis. So if we have a negative number times x, and that number is less than 0, then the graph is going to reflect across the x-axis. So as long as that number that's multiplied by our x, or our slope, as long as our slope is less than 0, it's going to reflect over the x. So something going up is now going to go down. If that number happens inside parentheses and it's multiplying by x, so if our slope is multiplying by x, but this time they're inside parentheses, then instead of going up, it's going to go down. So instead of calling it a reflection over the x, we're now going to say that it reflects over the y-axis. So this line would become over here, and this line would become over here. Whereas this one, this goes down here, and this goes up there. So we have reflections across the x-axis and reflections across the y-axis. Let's go ahead and look at some problems and determine what's happening. In this example, we got to describe the transformation that happens in this equation from this equation. So as it relates to the f of x equals x. So looking at this, we can tell that they're different. First, we started with an x, and now we have 0.7x. So that's a number between 0 and 1, because it's 0.7. Since that's between 0 and 1, and it's inside parentheses, that means we're going to talk about horizontal. Now, you might have to go back and look at your rules and figure out that if it's inside parentheses, which horizontal piece is it talking about? Is it a horizontal stretch or is it horizontal compression? And in this case, it's a horizontal stretch by 0.7. But now we need to think about this too. It was a positive x, and now it's a negative inside parentheses with the x. So since it's a negative on the inside, that's going to be a reflection. And since it's inside parentheses, it's over the y-axis. And that's the answer for this problem. These are the two types of transformations happening. And it's two types because I started with x, and now I have two different things happening. I have the 7 and the negative. So that's what we're going to be doing. So we have talked about all four types of transformations. We talked about reflections, we talked about dilations, we talked about moving up, moving down, moving right, moving left. Now we're going to put it all together by looking at equations and establishing what's happening with those equations. If you feel like you can do this, that's great. If not, I'm going to help you out, and we're going to practice some in class, and we're going to make sure that we really do understand what's happening from graph 1 to graph 2. So let's go ahead. So here's one example that we're going to practice that has more than one transformation happening. So if I'm looking, I'm starting with x. I have a negative, that's one thing. I have a 3, that's another thing. And then I have a plus 2. So this graph has three different transformations happening. So we have to name all three things that happen to start from here to get to there. So let's look at our problem. First, we're going to look on the inside of parentheses. Inside parentheses, and it's adding a number. So if we're adding on the inside parentheses, that's either going to move a graph to the right or to the left. So we need to think about this number that's adding. Is that a positive number or a negative number? What do you think? Hopefully you're thinking that that's actually really a negative number because we started with x minus h, and two negatives make a positive 2. So this actually means that our h is equal to negative 2, which means that our graph moves left 2 spaces, or 2 units. So our graph is actually going to be moving left by 2 spaces. Now, we're going to look at the 3, and notice that the 3 is outside parentheses. So we have our a is equal to 3, which means that it's bigger than 1. Since it's bigger than 1, and it's outside parentheses, that deals with vertical. So we're going to say that this is vertical, and vertical means that we're going for the y-axis. Are we getting closer to the y-axis, or are we going further away? And since it's a number bigger than 1, we're getting closer. So this is a vertical stretch by 3. So far, we said that this graph moves left by 2, and it kind of stretches by 3, which means it's getting closer to the y-axis. And the final thing is that negative. So that negative sign with a means that our graph is going to reflect, and since it's outside parentheses, it reflects over the x-axis. So these are the three things that this graph does. This graph is going to go from going up to now going down, and it's going to be from a 1 slope to a more steep slope. So it's going to get closer to the y-axis. And the last thing that's going to happen is it's going to be steep, but it's going to move left by 2. So it's going to be shifted to the left just a little bit by 2 units. So these are the 3 things that the graph would be doing. So we just finished our lesson. We've only really did 4 examples throughout this lesson. We did an example with the graph moving up or down. We did an example with the graph moving right or left. We did an example with the graph being reflected. And now we did an example with a graph that has 3 different things happening to it. So right now we hopefully have a kind of grasp of what's going to happen. We're going to practice a few questions in class and see if we can identify the things happening to the graphs. And that's really all we're going to do for this lesson, because in this lesson we're talking about the transformations. And our transformations are dilations, reflections, and translations. So hopefully you guys like this video. Hopefully I covered everything to where you guys can understand it, and I will see you guys on Monday. Make sure you have these notes ready to go when you come in.